Exercise 10.1 says a cross between white and yellow summer squash gave progeny of the following colors. It has it 155, 40, and 10 for white, yellow, and green. It says, are these data consistent with the 12:3:1 ratio predicted by a certain genetic model? Okay, and it says use a chi-squared test with alpha equal at 10%. So for this, we first have to find out what our expected numbers are. So the frequency that we counted are these numbers, and for expected, we have to find out what we need. So if it's a 12:3:1, that means 12 out of 16 will be white, 3 out of 16 will be yellow, and 1 out of 16 will be green. Okay, we have a total of 155 plus 40 plus 10 for a total of 205 flowers, or 205 squash, I'm sorry. So 205 times 12/16 is 153.75. Here we have 38.4375, and we have 12.8125. So these are the expected numbers for each category. So they look similar, but we have to find our chi-squared statistic. So our chi-squared statistic is expected minus, the observed minus the expected squared divided by the expected. I guess if you have expected minus observed, because you're squaring it, everything comes out to be positive anyway. So here we do 155 minus 153.75 squared divided by 153.75. 40 minus 38.4375 squared divided by that 375 plus 10 minus 12.8125 squared divided by 12.8125. Okay, so square that. This number comes out to be 0.01062 plus 0.06352, and oops. Okay, and here we have 0.61738. And now we add all of these numbers up. And I'm getting a total of 0.69106. Okay? And here are degrees of freedom. We have 3 categories. So it's 3 minus 1. We have 2 degrees of freedom. We look up 2 degrees of freedom in our chi-squared table. And we see that at 2 degrees of freedom and a chi-squared statistic of 0.69106, our tail probability is going to be greater than 20%. So this leads to tail probability greater than 20%. Looking it up in the chi-squared table. And so, with alpha equal to 10%, we do not reject the null hypothesis. And in this case, null hypothesis is data, or the model fits the data. Okay. The model of 12 to 3 to 1. And the alternative is that the model does not fit the data. And so here we do not reject the null hypothesis.